Hey everyone, welcome to Armchair Technician. Today we're going to be taking a look at a real artifact in the history of rock and roll. This is a Gibson manufactured amp from the mid-50s. Before we get inside of it and take a look, we're going to give you a little bit of a history lesson.
This particular model of the Gibson Les Paul Jr. was a practice amp manufactured from 1954 until 1957. It was designed to compete with another popular practice amp of that day, the Fender Champ, and the inner workings of both of those amps are strikingly similar. Looking at the date codes and serial numbers, we can determine that this amp was probably built in 1956. For its age, this amp is in relatively fair condition. The tweed covering, speaker grill cloth, and original handle are all still intact. However, when we look inside, we can see a serious state of neglect and some pretty shoddy attempts at repair work. And seeing all the rust and corrosion on the inside, it's obvious that this amp needs a lot of TLC. It's also likely that this amp has not worked in many, many years. So we're going to do what we can to bring it back to life.
Okay, so when I first opened up this amp, immediately you can tell that it's not original. Obviously, these electrolytic capacitors are a fairly recent addition. All of these caps, actually, these here, and this one is actually, I checked the schematic for this amp. This one isn't even really supposed to be there. That might have been like a mod or something that someone did sometime in the past. This is also incorrect. I think it's something that they just had on hand and they just threw it in there. It's not the correct value. A lot of these resistors are original, like this one here. This one, you can see how they're just crusty looking. I mean, there's a lot of crusty shit inside of this amp. The power cable is an old two-prong. You can see it's like a brown lamp cord. I'm going to change that out. This is the first thing I'm going to do. In fact, I didn't even want to turn on this amp until I changed out the power cable. But upon closer inspection, I realized that it was probably okay. The pilot light, the switch, the fuse assembly, the volume knob, and the two input jacks are original, as is the chassis, and it still has the original handle here, which is very desirable, and it is not broken. However, I'm not picking this thing up by the handle because I don't want it to break while it's on my bench. That would suck. But that's very desirable for these handles to be intact. About the work that's been done on this amp, I will say it's very sloppy. I feel like these components are good. However, this is B+ voltage here, so this is like hundreds of volts of DC current flowing through these bare wires. If one of these were to get jostled and touch the chassis or something, or touch somebody, that would send hundreds of volts of direct current directly into your body, and that would be potentially lethal. So this is really, really terrible work, and it's dangerous, and I'm going to take all this out, and even though the components are probably still good, I'm going to just redo everything and make sure that the wiring is safe. So we'll get started. The first thing I'm going to do is replace this two-prong power cable and put a three-prong on there, and then we'll go from there to fix the rest of the circuit. Okay, the first thing we're going to do is desolder the leads on this power cord. So, got my trusty iron nice and hot here. It doesn't appear that this is the original power cord. This looks like an old, like a Christmas light extension cord, kind of. They had the end cut off, and okay. So we got this. Okay, so I've got this three-prong cable that I just had laying around. I think it was like a computer or computer accessory cable. The wall plug end looks like this, pretty common. So you've got three wires here. This one is the ground, And I double checked these. I tested them with a continuity tester on my voltmeter to make sure that this wire is actually going to the ground. The blue one is the hot wire, and the brown one on this cable is the common wire. So the blue one is going to go over here to the fuse assembly. The brown one is going to go to the switch. And then this wire, which looks yellow in the video, but I'm going to solder it to this grounding post, which is one of the transformer mounting posts. It already has some stuff that's grounded to it, as you can see, such as the pilot light and this center tap from the power transformer. So I'm going to put this ground wire on this post. Also note, the ground wire should always be a little bit longer than the other two leads. This is in case something happens and the power cord gets completely yanked from the chassis. This ensures that the ground will be the last wire that pulls out. So the hot and the common wires would, in theory, disconnect first, therefore it wouldn't be as much danger if the ground wire is the last one that might get pulled out. So it's just a little thing that I like to do just for a little bit of extra safety. So I'm gonna hook these up and then we'll move on. Okay, so we got this 3-prong cable soldered in, this power cable. So we've got the hot wire here going to the fuse assembly. We've got the common wire going to the switch. And then this is the ground wire here that we have soldered onto this lug that is this is a bolt coming from the power transformer, which is underneath the amp under here. So we basically went from this plug, which is very outdated and can be somewhat dangerous, and we put this guy on here. So it's just more sturdy, more modern, more safe. I will say that a lot of times with amps of this age, vintage amps, collectors and stuff, they tend to want to purchase them in original condition. They have more value on the market when they have all original parts. So for an amp like this, if I had opened this up and this was all original, I would go back to the customer and ask them what their intention is for this amp. Since there was a lot of parts that have been changed out over the years on this amp, I'm just gonna do what I think is best and get this amp up into a good working condition for, you know, something that a player can enjoy. And I'm not too worried about affecting the value of it because it's already been compromised anyway. So I'm just going to make it the best that I can from here and get it sounding good. Okay, now that that's done, we're going to get into a little more fun part. So I mentioned earlier that these are electrolytic capacitors. So these are in the power section of the amp. This is what powers the tubes and the output transformer. Whoever installed these did a really terrible job, and I tested the voltage that's running through each of these bare wires, and there's somewhere around, well, this one is at 350 and this is at 400 volts DC. That is enough to at least put you in the hospital, maybe stop your heart, maybe kill you. This is really, really poor work. Please be careful when you're dealing with high voltages. If you don't know what you're doing, then you can get yourself killed, and I know you've heard this 1,000 times from everybody who's on the internet talking about tube amps, but this is really, really important. So I'm gonna desolder these. I think the caps are still good, but I'm just gonna rewire them and reinstall them in a much more clean and safe way. So I'm gonna work on that now. Now that I've got the capacitors out, I want to reinstall them and sort of secure them in a better way. So there's a hole that already exists in the chassis here, This was where the original fastener thing that the capacitors, the original capacitors, were held intact. Well, that has been removed, but the hole obviously is still there. So what I'm going to do is take a little bit of sandpaper and just sort of get all the rust and corrosion off. And then I'm going to mount this terminal strip, this guy right here. It's a really small, super simple, but this is going to help me really secure those capacitors so they're not kind of floating around inside the chassis. So that's what we're going to do next. And this is a little trick that one of my mentors showed me. If you put a little nail polish over this nut and bolt that's holding down that terminal strip, or any of these really, it helps keep it from coming loose. So makes sense, right? I'm also going to redress and resolder these leads. These are original wires. These are coming from the rectifier, and you can see that this one has like black on the tip of it, meaning that somebody tried to solder it and it got too hot, so it burned the insulation a little bit. There's two of these. So I'm just going to clip the ends off and strip the insulation down, and so it'll be a fresh, clean, new contact point. So it's not something you really have to do, but I just like to do it. It makes the job look a lot cleaner, and it's a more fail-safe installation. Okay, so I've got the electrolytic capacitors reinstalled. The terminal strip that I mounted before to the chassis is right here. It's in between these two, and this is the ground post for all three. So we've got the ground from this one going to here, as well as these two here. Now I haven't connected the positive ends of these two caps yet, because I'm going to make sure that everything's correct down the line, like with these leads here that I removed earlier. Plus, I'm probably going to take these off and put brand new wires, or at least redo the ones that were there because they were really sloppy. Also, I put some shrink wrap on the positive end of this just to make sure nothing, you know, touches it and receives about 450 volts of DC current. This is soldered directly to the rectifier tube socket, and it's getting supplied by the high voltage here from the transformer. At this point, I'm going to start replacing components that I see are, well, these are original. These two resistors here, those are definitely original, and this amp was built in 1955 or 56, so these are over 60 years old. I've got some of these on hand just in my workshop, so I'm going to go through the process of removing these old resistors and replacing them with new ones of the same values, of course. So we're going to start doing that next. Okay, well, as you can see, we've pretty much replaced all these resistors. This one, these two, this big guy right here, and this one. So I left all the capacitors there because these are pretty much new anyway, and also soldered back these two leads for the B+ voltage to power the plates and grids on the tubes. Also switch this out just with new components just because I have them on hand. So I'm just going to give this guy a clean slate. Also, in the meantime, I did test the output transformer and the speaker, which both appear to be working. So now we're gonna fire this thing up and see if she sings. Well, looks like we're getting sound out of this amp, which is a great success considering it wasn't producing any sound when we got it in here. The speaker is a little bit crackly. which is to be expected since it is the original speaker. It's got a really good vibe to it, really cool sound. This would be a great recording amp. Thanks for watching. Alright, thanks for watching. We hope you enjoyed the video. Please like, comment, and share, and otherwise below, and we'll see you next time.